Welcome back to Verilog videos. In this video, I want to be discuss about level of abstractions in Verilog. So actually, we have three levels of abstraction mainly. What is the level of abstraction here? Already in previous videos, we discussed about what is abstraction. In this Verilog, what is the main benefit is we can hide the details of the implementation and the technology behind that any design, otherwise any implementation. Okay, so here actually we can implement the design, otherwise you can write the code, otherwise you can development any circuit, otherwise a gate, otherwise a switch level. Actually mainly we have three types of level of abstractions. First one is data flow modeling, means data flow level of abstraction. Next one is gate level, and the third one is the switch level. Okay, so here we briefly we will get an idea about what is data flow and how to write a Verilog code for that, and what is the gate level abstraction and how to write the code for that, and the switch level how to write the code for that. First I am going to be discuss about data flow modeling. Data flow modeling means already we have written some programs in those concepts. Data flow modeling, I have written some programs by using end gate. Okay, I implemented a Verilog code, and I want to be implement like not gate and different. So here in data flow modeling we will mainly focus on the functions that defines the working of the circuit instead of the gate structure. So I want to be focused mainly on the circuit. Okay, the gate structure I don't want to be considered, but instead of that gate structure I want to be design the functionality of that particular circuit. So data flow modeling has become a popular design approach, because here for the implementation of, otherwise the writing of the Verilog code for this data flow modeling is very easy. Here there is no need to use any like more number of predefined words here, so that's why it is simple to design of the data flow modeling in a Verilog code. The data flow modeling style is mainly used for describe the combination circuits. So actually we have two types of circuits. First one is combination circuit and second one is sequential circuit. The difference of combination circuit and sequential circuit, we can say the combination circuit means we are combining either two or more circuits, means more gates, we can say more logic gates, then we can form a circuit that is called a combination circuit. Sequential circuit means if we are combining with these combination circuits with the one backup memory, so that is called a sequential circuit. Okay, so here the mainly you can remember, if you are watching any assignment keyword in that code, that can be hit is data flow modeling of a Verilog code. Now, a value is assigned to a data type called a net. Already I discussed this data types, net, register, those type of data types, and I discussed about assign keyword also in the previous lectures. So here the continuous assignment statement starts with the keyword assign keyword, and this type of continuous assignments we can use in a data flow modeling. Okay, I mean it's a data level abstraction modeling. So here the syntax is assign a delay. Delay means we can say it is a time level, and RHS net is equal to LHS net is equal to RHS expression. So LHS net, I mean net is like it is a data type, it can't store any value, it is like a wire. RHS expression, so what is expression? For example, I want to be implement and logical end. So here I can say LHS net means y is equal to a ampersand b semicolon. So a and b I am using, this is the expression, then I am assigning to the say net value. Net means it can't store any value, just it's for providing that particular output. Okay, for example here see, the output is showing like that, as in out1 is equal to in1 and in2. So perform the functions of in1 and in2 and assign the result to out1, and same like that. Not means it is we are invert that function, and assign hash to z of 0, that is equal to hash to is the delay, means it can hold some amount of time, means 2 milliseconds. Okay, so it is going like A B A R and B B A R and En. So this is one type of expression I am assigning to the z of 0 value with a negation symbol. Okay, this is means like when we are going to be designed at the level of data level, then you can write this type of code. Means assign, I am assigning some expression to particular net value. So this is wherever you are watching this type of development or this type of Verilog code, it is a data level modeling. Remember this thing. Next I am going to be explain gate level modeling. So what is gate level modeling? So apart from that, so there I am using some circuit designing instead of that gate structure. So here, but here I am mainly focusing on that gate, the logical gates. It is the combination of the logical gates, otherwise the elements of the logical gates like and or elements. If I am using to build the functionality, then the model is becoming, it's like gate level model. Okay, it becomes a natural to build a smaller deterministic circuits at a lower level by using a combination element such as gates like AND and OR. Okay, modeling done at this level is called gate level modeling, and as it is involves gates, so here we are involving everything is under based on the gates. So we have logical level gates, like 7 types of gates we have. So for designing any circuits, we are including or we are involving those gates for developing any functionality, otherwise anything. For example, I want to be implement the 4 by 1 multiplexer. So 4 cross 1 multiplexer, if I want to be designed by using AND gates, otherwise by using the combination and OR gate. So here, so I want to be include those type of logical gates for developing any combination circuit design that can, that level of abstraction we can call it is a gate level abstraction. Okay, here syntax I am using, so AND, NAND, OR, NOR, XOR, XNOR. These are the keywords. Also, if you are using this type of keywords when while you are designing the code of the Verilog. Okay, so BF, buffer, and not. So we can create some instance names. You see, these are the output one, output two inputs we can take like this. These are that. Buffer like this means like actually in gate level modeling we have two primitives. Okay, first one is a single input gate primitives and second one is a multiple input gate primitives. Single input gate primitives, if you are going to be discuss, single input gate primitives have a single input and one or more outputs. So here the gate primitives under like not, buf, buff, okay, not if, and buff if also have a control signals. Okay, some control signals also we can say under that gate primitive, single input gate primitives. So here the syntax we can say module gates input a comma b comma output c comma d. So inputs I am taking a comma b and outputs I am taking c comma d. So I am implementing by using the keyword baf, c comma c is the output, a comma b I am taking the inputs. Okay, same not I am implementing. So this is the code. Okay, here I am writing, for this code I am writing a test bencher, means test bench. Already I discussed this test bench, what is a test bench and how to implement the test bench in one video. Please watch that video and you will get an idea. Okay, module tb. So here when I am creating another module, I said tb is the module name, and register a comma b. So I am taking the inputs in the register data type, and after that I am writing wire c comma d. I am taking wire is a metadata type, c comma d, because those are the outputs. So integer a, sorry, integer I am taking one, I am declaring integer data type. So next I am taking this gates as the module of previous one, and I am creating some instance here. U0 is instance. I am connecting previous inputs with the here the tester out inputs and outputs. I am connecting like dot a of a, like that, dot b of b. This is the syntax and this is the method for connecting those from one module to other module of those inputs and outputs. Okay, next I have to use the initial keyword and begin. So actually here two types of initial and begin keywords. If you are using only initial keyword, then for execution you have